So now that you understand a little bit more about static methods, let's talk about why. Why is it advantageous to not have an instance of the object? So as we've previously learned through our different topics of object-oriented programming, right, every object has its own copy of all the instance variables in a class. So let's look at an example. If we have a class and we set it up and we create an instance variable, right? Here's our variable. Then every time we create a new instance of that particular class, then it gets its own copy of that variable. And then maybe we put a value in it. And then we can create another new instance and we can have its own variable and it can have its own value. And this goes on and on and on and on for how many ever instances of an object that we need. In certain cases, only one copy of a particular variable should be shared by all objects of a class. So in this scenario, we have a class, and it could still have its variable that every instance of the object, right, could then change. But maybe then we also have a static member, right, static variable or a static method. And through this, we can use the same piece of information. So let's say we put the value of 5 in there. And so it wouldn't matter if we had a new instance, then this variable, which is open to everyone, could have its own value. Whereas the static variable is never going to have its own value. It's always going to point back to the class. Right? So as we create new instances, I can put my own values in there. Every time I create a new instance of the object, that static item is going to point back to its parent. And it's always going to be 5, or it's always going to be whatever value it should be. So in this format, we get this class-wide information where all objects of the class share the same piece of data. So let's talk about an example of how this kind of class-wide information works. So suppose we are making a video game, and our video game contains Martians. Right? And here are our Martians. Okay. So in our game, each Martian tends to be brave and is willing to attack other space creatures when it's aware that there are at least 4 other Martians present. So we have to have 4 Martians. And if fewer than 5 Martians are present, then each Martian becomes cowardly and won't attack. So each Martian, we can think of this as our class, right? So every time we create a new Martian, then we are creating an instance of the object, right? So Martian class, Martian class, Martian class. Well, in this scenario, each Martian needs to know the Martian count, right? So it can look at and say, okay, well, how many Martians are there? So if we have this overarching idea of a Martian count that all members of the class can look back to that isn't tied to a particular instance, then it wouldn't matter if this Martian has 10 hit points and this Martian has 15 hit points and this Martian has 15 hit points, right? Because that could be my class level variable that is pointing to each instance of the object, but each Martian is always going to point back to the Martian count so that we can keep an accurate track of how many Martians are on the screen. Right, if we don't do this, then every Martian would have a separate copy of the instance variable, and every time we create a new Martian, we would have to update that instance variable for every Martian, right? And so that wastes space. And it wastes time and it wastes memory, and we end up with redundant copies of the same piece of information. And so ultimately, when we're thinking about what pieces of information I need access to and how my class needs to be designed, we often run into this instance where We don't want variables to be tied to an instance of the object. We want every instance to ultimately point back to this piece of information. And so that's how you know when you're designing your class whether or not you need static methods or static members of your class.